Have you ever gotten a lab report back and it just looks like a whole bunch of letters and numbers that don't make any sense? Well, what if I told you that a routine blood test, specifically a complete blood count, or a CBC, is actually less like a confusing document and more like a detective's case file, just packed with clues about your health? So, let's dive in. We're going to focus on one of the most important parts of that CBC, the red blood cells, and really learn to read the secret story that they're telling us. I promise, by the end of this, you're going to see your lab results in a completely new light. You know, every good investigation has to start with gathering the primary evidence. And in the world of your blood, there are three main clues that every single hematology detective looks at first.
Okay, so here's our primary evidence, these three key parameters. First, you've got the red blood cell count, or RBC. That's pretty simple. It's just how many of these little guys you have. Next up is hemoglobin. That's the actual protein inside each cell that grabs onto oxygen. And finally, there's hematocrit, which tells us the percentage of your blood that's made up of these red cells. Think of it like this, right? The RBC is the number of cars on the road, hemoglobin is how much stuff each car can carry, and hematocrit is how much of the highway is taken up by all those cars. Together, they give us that first big picture.
Now, any good detective has to know if their evidence is actually reliable. And pathologists, they have this cool little trick up their sleeve called the rule of 3. It's super simple. You just take the hemoglobin number and multiply it by 3. That result should be really, really close to the hematocrit percentage. So for instance, if a patient's hemoglobin is, say, 15, their hematocrit should be right around 45%. It's just a quick and clever way to double check that the lab's measurements are on the level before you go any further.
All right, so we've confirmed our primary evidence is solid. Now it's time to pull out the magnifying glass. We've got to look closer at the red blood cells themselves. And for that, we use a special set of tools called red cell indices. This right here, this is our forensic kit, the red cell indices. These give us a super detailed profile of the red blood cells. Now, they tell us all sorts of things: size, weight, color, even how much they vary. But for our investigation today, we're going to focus on the two biggest clues: the average size of the cell and its color. First up is MCV, or mean cell volume. This tells us the average size of your red blood cells. Think of it like identifying the model of the getaway car in a heist. Are the cells microcytic, meaning they're way too small? Well, that might point us towards something like an iron deficiency. Or are they macrocytic, way too large? That could be a clue for, say, a vitamin B12 deficiency. Just the size alone is a major, major lead. Next, we look at the color using something called MCHC, the mean cell hemoglobin concentration. Basically, this tells us how much hemoglobin is packed into each cell. Are the cells hypochromic, paler than they should be because they're low on that oxygen-carrying stuff? Or are they normochromic, with a nice, healthy, rich red color? This is another absolutely vital piece of evidence for our case file. So the numbers, they give us one part of the story. But now it's time for some visual ID. We're going to look at a police lineup, but instead of suspects, it's going to be red blood cells, and we're going to see if we can spot any unusual characters. Okay, the official fancy term for having a bunch of different shapes in your red blood cells is poikilocytosis. Yeah, I know. But here's what it means. A normal red blood cell has this nice, consistent, donut-like shape. When we start seeing all kinds of different shapes in the mix, it is a huge red flag that something is off with how they're being made or how long they're surviving. And here they are, our first spiky suspects. On one hand, you have acanthocytes, or spur cells. Look at those irregular, thorny projections. That's a classic sign of severe liver disease. Then you've got echonocytes, or Burr cells. Their spikes are a bit smaller, more uniform, and they often point towards kidney failure. See? Their unique shapes are direct clues to totally different problems. And the gallery of suspects just keeps going. Of course, there are the infamous sickle cells, whose crescent shape is the absolute hallmark of sickle cell disease. We also see target cells, which literally look like a bullseye and can also point towards liver disease. And then you have these teardrop cells. Their shape suggests the body is so desperate for red blood cells, it started making them in weird places, like the spleen or the liver. It's incredible. Each shape really does tell a unique story. But our investigation isn't over yet, not by a long shot. Sometimes the most critical clues are hidden from view. So now we need to look inside the red blood cells for any incriminating evidence that's been left behind. These are called inclusions. To find these hidden clues, we need some special tools. It's just like a crime scene investigator using different chemicals to reveal different evidence.
A lab technician uses different stains. The standard right stain, for example, can reveal leftover DNA fragments called Howell-Jolly bodies, which is a sign the spleen isn't working right. But to see other clues, like clumps of damaged hemoglobin known as Heinz bodies, you need a totally different special supervital stain. It just goes to show you have to know what you're looking for to use the right tool for the job. And this is where it all comes together in the real world. Finding a very specific type of inclusion called basophilic stippling, which looks like little blue dots of leftover RNA scattered inside the cell, is a classic textbook sign of lead poisoning. This one microscopic clue can be the key to cracking a major diagnostic case and getting a patient the urgent help they need. I mean, it is truly fascinating stuff.
So, we've gathered our evidence, we've analyzed it with our forensic tools, we've examined the suspects in a lineup, and we've even uncovered hidden clues inside the cells. Let's do a quick review of our detective's toolkit.
So there you have it. That's your toolkit. You start wide with the big three, RBC, hemoglobin, hematocrit, to get the lay of the land. You use the rule of 3 to make sure that evidence is solid. Then you zoom in with the indices to analyze the size and color. And finally, you examine that lineup of unusual shapes and search for those hidden inclusions, the final tiny clues that can crack the entire case wide open. So the next time you see a blood test result, I want you to try not to see just numbers and ranges. See it for what it really is. A detailed, dynamic story written in the language of your very own cells. It's an incredibly powerful tool, and now you know a little bit more about how to read it. So what other secrets are just waiting to be discovered in there?